Alright, welcome to this video, and in this video we're going to be looking at 7 other linear differential equations. Now, for 7 other linear differential equations, they come in the form of d square y over dx squared plus, input a, d square y over dx squared plus dy dx plus cy is equal to 0. They come in this form, and basically you can express them as ar squared plus br plus c is equal to 0, and then you can solve them using the quadratic method, and that's going to be r is going to equal to negative b plus or minus root b squared minus 4ac over 2a. So you have this, right? So you can solve them using this method. And so now in solving, we have 3 cases, right? We have case 1. For case 1, it happens when b squared minus 4ac is greater than 0. When it's greater than 0, we say that the roots are real and unequal, right? What this means is that, let's say we have 2 and 3, they are both real roots, but they are unequal. We can have minus 2 and 4, they are both real, but they are unequal. When this happens, the formula that we use is y is equal to c1 e to the power of r1x plus c2 e to the power of r2x. Very, very simple, where r1 and r2 are the roots of the equation. Then we have for case 2, when b squared minus 4ac is equal to 0. Here we say the roots are real and equal, right? For cases where you have 2 and 2, 3 and 3, that's what we have. So now the formula for this is y is equal to c1 e to the power of rx plus x c2 e to the power of rx. The reason why we don't have r1 and r2 is because the roots are equal, so it does not matter which one is r1 or which one is r2. Then for case 3, we have b squared minus 4ac is less than 0. When this happens, we say the roots are imaginary and complex, right? We say the roots are imaginary and complex, and the formula we use is y is equal to e to the power of alpha x multiplied by c1 cos bx, not b, beta, plus c2 sine beta x. Then we have this. So these are the formulas that we use for the 3 cases, right? So we're going to solve 3 questions to see how these 3 cases will play out. All right, let me clean this. All right, so now for the first question, let me see. All right, so for the first question here, we're going to have y prime prime minus 5 y prime plus 6 is equal to 0, right? So this is the question that we have. So plus 6y is equal to 0, and I'm sure that you know that y prime prime is the same as the square y over dx squared, and y prime is the same as dy dx. So we're going to replace this as r squared minus 5r plus 6 is equal to 0, right? And then we're going to solve. Here our a is equal to 1, our b is equal to negative 5, and our c is equal to 6, right? So r is equal to negative b, which is going to be 5, plus or minus root b squared, which is going to be 25, minus 4ac, which is 4 times 1 times 6, which is 24, over 2a, which is 2. R is equal to 5 plus or minus root 25 minus 4, which is 1. Root 1 is 1 over 2, and then our r is equal to 5 plus 1 over 2, which is 6 over 2, which is 3, or 5 minus 1, which is 4 over 2, which is 2. So our root is 3 or 2. So now we can see that the roots are real and unequal because they are not the same. So the formula we use is y is equal to c1 e to the power of r1x plus c2 e to the power of r2x. So our y is going to be equal to c1 e to the power of 3x plus c2 e to the power of 2x, and this is going to be our final answer for this question. Now we're going to take the second case. With the second case, you can source other questions from the material, HK that's materials. So now for the second case, we have a question: y prime prime plus 4y prime plus 4 is equal to 0. So now this is going to be r squared plus 4r, right, plus 4 is equal to 0. This will be 4y. is equal to 0, and then our A is equal to 1, our B is equal to 4, and our C is equal to 4. Here we're going to have R is equal to negative B, which is negative 4, plus or minus root B squared, which is going to be 16, minus 4AC, which is 4 times 1 times 4, which is 16, over 2A, which is 2. Our R is going to be negative 4 plus or minus 0 over 2. Then our R is going to be equal to negative 4 plus 0 to negative 4 divided by 2, which is going to be negative 2, or negative 4 minus 0 is going to be negative 4 divided by 2, which is going to be negative 2. So now we can see that the roots are real, but they are equal. And then the formula we use is y is equal to c1 e to the power of rx plus x c2 e to the power of rx. Here we can see that we did not demarcate it, we did not separate the values of r as r1 and r2. This is because the roots are the same, so it does not matter which one is r1 or which one is r2, right? So y is equal to c1 e to the power of negative 2x plus x c2 e to the power of negative 2x. And this is how we solve for case 2, and then we're going to check for case 3, right? We're going to check for case 3 now, which is the last case under second order linear differential equations. Right. So now for case 3, when so this question is y prime prime plus 4y is equal to 0. So we should solve when y of 0 is equal to 4 and y prime of 0 is equal to 6. So these ones are basic conditions, so we have to first solve the equation itself before we get to this method. So now y prime prime, so this is going to be r squared plus 4 is not going to be 4y, right? Because y is not y prime. As it means it was y prime, then it's going to be 4y, right? So equal to 0. Then we have r squared is equal to negative 4. Then we'll take the square root of both sides, right? So we have the square root of r squared, which is going to be r. This is going to be equal to plus or minus root 4 times root negative 1. So r equals to plus or minus 2i, because the square root of negative 1 is i. So we have root 4, which is 2. So 2 times I is going to be 2i. So this is the root, right? Basically, and you can see that this is imaginary because of the I. It's complex, right? So it's imaginary or complex, and basically the root comes in the form of alpha plus or minus beta I. So now what you're going to do here is that you're going to now because here we have nothing in this place, so it means that automatically it's going to be 0 plus 2i. So it means that alpha is equal to 0 and our beta is equal to 2, and our formula is y is equal to e to the power of alpha x in bracket c1 cos beta x then plus c2 sine beta x. So we have this, and then we're just going to apply our values. So y is equals to e power of 0 times x, which is 0, c1 cos 2x plus c2 sine 2x. This, so these are, we'll just simplify. E to the power of 0 is 1, so we're going to have c1 cos 2x, then we have plus c2 sine 2x. Now basically what we have here, we have all our values. So now basically now we're going to satisfy this condition that we have here. So we have y of 0 to be equal to 4 and y prime of 1 to be equal to 6. So we have all these conditions, and we are going to satisfy this condition if we are to get our final answer. So now what this means basically is that 0 is going to be our value for x and 4 is going to be our value for y. So now we're going to put 4, then we're going to have c1 cos 2 times 0, which is going to be 0, plus c2 sine 0. Sine 0 is 0, cos 0 is 1. So we're going to have 4 is equal to c1 times 1, which is c1, plus c2 times 0, which is 0. So c1 is equal to 4. Now we're going to go for the second condition when y prime of 0 is equal to 6. So now y prime basically is just the derivative of y. So we're going to be deriving this equation. So we have y prime to be equal to derivative c1 is going to be a constant, so we derive cos 2x, which is going to be negative 2 times c1 sine 2x plus 2 c2 cos 2x, and then we're going to put our values where x is 0 and y is 6. So when we have 6 equal to negative 2 c1 sine 0 plus 2 c2 cos 0, right? Remember, sine 0 is 0, cos 0 is 1. We have 6 to be equal to 0, then plus 2c2, right? And then c2 is equal to 3, and then we're going to rewrite the original equation. So we're going to rewrite it imputing the values of c2 and c1. So we have y to be equal to 4 right? We have 4 cos 2x, then we have plus 3 sine 2x, and this is going to be the final answer to this question. And this is how you do second order linear differential equations.